class, we are going to talk about properties of metals again, but not physical properties, chemical properties. Whenever I say chemical properties, it means that we are going to talk about their chemical reactivity. It's all about chemical reactivity. How can metal react with maybe oxygen, carbon dioxide, or whatever at certain given conditions, right? So even today it's going to be a lot of interaction between you and me, because most of the chemical properties are the ones which either we have studied in our earlier grades, otherwise we have at least seen it once around us in our lifetime. Yeah, so last class I have shown you the textbook and we came across an activity called as activity 1 3.8 or something, yeah, where we have to recall burning of magnesium and reaction of sulfur with atmospheric oxygen. How many of you remember burning of magnesium? We discussed in first chapter, right? To study the nature of what? To study the nature of a chemical reaction, to study the characteristics of chemical reaction, we have used the same example. Anyone who can brief what happens? Anyone who can give a brief what happens when magnesium is burnt in presence of oxygen? Yeah, Harshita is the first one who responded. So Harshita, I'm unmuting you. So be ready, be ready. Harshita, I should find your name. Give me a second. Yes, got you. Harshita Tripathi, right? Well.
Hello, ma'am.
Hi Harshita, good evening.
Well, ma'am, when magnesium is burnt, first the magnesium combines with the oxygen to form magnesium oxide, and the characteristic which we see is that it burns with a dazzling white color.
Okay, dazzling white flame, isn't it? Yeah.
Yes, ma'am.
Right. And what is the resultant? Is there any new product formed? Any
Yes,
new
ma'am.
product?
Magnesium oxide.
Magnesium oxide is the new product. Heat energy is released and light energy is also released.
Yes, ma'am.
Studied, right? Thank you so much, Harshita.
Thank you, ma'am.
You know what? There are 3 students in the class whose name starts with H. Harshit Mishra, Harshita Tripathi, and Harshit Kamsali. 3 students, and I actually Hiba is also there, but then these 3 guys are Harsh, right? So I will have to be really very careful when I take out your names. Yeah, well, anyways, let us come back. As Harshita Tripathi has rightly explained, burning of magnesium, it looks like a white dazzling flame with the help of which magnesium oxide is formed. Whenever we take a magnesium ribbon, burn it, it just burns off, releasing light, releasing heat energy, and of course it also releases, forms ashes, which is nothing but magnesium oxide. I hope you all remember the image that I have shown you. Do you remember the real-time image of burning of magnesium, right? Well, so that is burning of magnesium. So in the last class, as a part of first chapter, we have seen the observations. We were just talking about how it looks like, but in today's class, we are going to analyze the ashes that we get. Yeah. Well, by the way, I have a news. Pavitra Anand, her sister's name is also Harshita. Yeah, right, that's cool. Now, that's about magnesium burning, and that is about the ashes of magnesium. They are just have you ever noticed the ashes of magnesium? You might have seen the activity in your class 10 or at least in class 8 or 7, right? It is very soft, correct? It's a soft solid which is amorphous. It does not shine and all. It is normal. Now let us come to burning of sulfur. So sulfur is a non-metal. You will get sulfur in form of a fine powder which has yellow color. This is how it looks like. You can lighten sulfur, it will catch fire and it will burn. It does not give any dazzling white flame and all. It doesn't burn with a bright flame, but it slowly burns. As it goes on burning, what happens is it does not give the product in either solid or liquid physical state. Then which physical state the product would be in? The product which is obtained would be in which physical state? Very good. We will be acquiring a gaseous stated product, and the product which is obtained, because it's a gas, we would always have to be careful about collecting this product. This activity also is being conducted, must be in class 7, but for your memory, take a look at this. Have you conducted this activity? You will take a sample of sulfur in a spatula which is bent, and then you will lighten it. Once it catches fire, you will keep it, introduce it into a jar, so that the flames, or sorry, the fumes which are evolved would be trapped inside the jar itself. And then you would have taken it and dissolved the fumes which are liberated in water. As a result of this, you will get a solution, and you would have analyzed the pH of the solution using litmus paper. Correct? How many of you remember? Okay, that's okay if you don't remember, because it's been some 2-3 years. No problem. I'm here to recall everything. Okay. So as a part of the study of chemical properties, we are talking about two aspects. Aspect number one is burning of magnesium and absorbing the product which is formed. Aspect number two is burning of sulfur and absorbing the product which is formed. Okay. So when we burn magnesium, it is Mg plus O2 leads to formation of 2MgO. If I take 2Mg, sulfur S plus O2 leading to formation of SO2. Both are burning only, right? Now, in the first case, what are you trying to burn? You are burning magnesium. And in the second case, you are burning sulfur. What is magnesium by nature? Is it a metal, non-metal, or metalloid? What is it? It is a metal, correct? And in the second case, sulfur. Sulfur is what? Sulfur is a non-metal, correct? So you are studying what happens when you burn a metal and what happens when you burn a non-metal. My dear students, if you are not making note of anything, please get a pen and page, because you are going to learn a few things which are not there in the textbook today. Yeah. So quickly keep noting down the thing that you find important or that you find essential, right? Well, so the first case is burning of metal. The second case is burning of non-metal. When metal is burnt, you got ashes, and when non-metal is burnt, you got fumes. That's not a big deal. But then what matters a lot for us now is the nature of the product. If you take these two products, add some water to both of them. Okay, you have added some water to magnesium oxide, which is solvent, and then you have dissolved it thoroughly. You got a mixture, you got a solution, correct? And in the second case, since SO2 is a gas, you carefully have added water and you have ensured that the gas is dissolved in this water, and here also you have acquired a solution. Now what should you do is, you should add a few drops of litmus, or at least get a litmus paper, dip it into the solutions and observe. So when this observation was made, amazingly, when litmus drops were added to a solution of magnesium oxide dissolved in water, magnesium oxide dissolved in water, right? When litmus is added, what was observed? It was blue in color. That means if you have added red litmus, it turned into blue color. If you have used a blue litmus, it remained blue color. The color of the litmus was blue. Yeah. Now observe the second case. When a few litmus drops are added to the solution of SO2 in water, amazingly it was found that the color of the litmus immediately turned red. If you had used blue, it would turn red. If you have used red, still it would be existing in red. So what does it indicate? The color of litmus is blue. In which natured compound, in which natured matter? If it is blue, that means the solution is a base. If it is red, that means the solution is an acid, isn't it? Okay. Let me quickly go back and see what all components are there in the solution. Firstly, it has water, and we all know that water's pH is very close to neutrality, right? So we don't need to worry about the behavior of water. So that means the basic behavior is basically due to presence of magnesium oxide, and the same way acidic behavior is essentially acquired due to presence of sulfur dioxide. From this, what can we understand? We can understand that the product obtained due to burning of a metal is basic by nature, and the product obtained due to burning of a non-metal is acid by nature. This is what we can conclude. And to be little more crisp, the metals, when they are burnt, they of course react with atmospheric oxygen, and the compound formed here can be called as, anyone in the class, what do we call them as? We call them as metal oxide. Correct? Metallic oxide or metal oxide. And if it is non-metal, we call it as non-metallic oxide. Correct? Any compound of a metal or non-metal with oxygen is called as oxide. If remember these things, with oxygen you call it as oxide, with hydrogen you call it as hydride, okay, with chlorine you call it as chloride. These are the ones which we study in today's class, remember them, okay. With fluorine you call it as fluoride, right? And then if it is bromine you call it as bromide. Remember these ones, okay. If you have OH, then you call it as hydroxide. This you are aware. We studied this in acids and bases chapter, right? Chapter number 2. Correct? OH hydroxide. Right, guys? And some more CO3 minus 2. If there is a molecule which is consisting of CO3 minus 2, what do we call it as? We call it as carbonate. This also we know, nothing new. Correct? And if it is having HCO3 minus 1, we call it as bicarbonate, right? Or hydrogen carbonate. Yes, and what else you come across? For now, this is the list. This is very, very important. Make a note of it immediately. Yeah, well, so now from this, what can we conclude is metallic oxides are basic by nature and non-metallic oxides are acidic by nature. In a short way, without confusion, you might remember this in this way. Metallic oxides are bases. We use a lot of internet these days, right? How many MB, how many GB, right? Yes? Yeah? Is this word familiar to us? Remember this MB. If it is metallic oxide, it is basic. The reason I'm giving you a shortcut here is going ahead, you would have to remember many such things, and ultimately there is a tendency that you might be confused. Yeah. So MB, whenever I ask you for MB, it is what? It is a metallic oxide, basic in nature, right? And of course, if you know the nature of metallic oxide, you would obviously will get to know the nature of non-metallic oxide, right? Both are opposite of each other. Is there anyone who needs a shortcut for that also? No, right? Yeah? Well, so I repeat, metallic oxides are basic by nature. In order to remember it, make this shortcut, remember this shortcut as MB. MB is a common term which we use while talk about data, right? Data in terms of GB, data in terms of MB. When you download an app, you look for how much space does it consume, how much data does it consume, isn't it? MB, M is for metal oxide, B is for basic nature, right guys? Yeah. Well, now this is what is the first property, first chemical property. First chemical property says that metal oxides are basic, non-metal oxides are acidic by nature. But then if you observe it in a different angle, you can also take this as an example of physical property, because see, we can also study the light effects of burning of metal and non-metal, right? Metals burn with a white dazzling, not white all the time, but then they burn with a dazzling flame. But non-metals burn slowly. It's a rapid combustion in case of non-metals, right? Even that can be noted, right guys? Yes, so now this is activity 3.8, and with the help of activity 3.8, we have understood the nature of metal oxides and non-metal oxides. So now I have a question to be asked from these points which we have discussed so far. So these questions might sound a little silly, but then they are very crucial. Question number 1. My dear students, do you think metals and non-metals can react with oxygen? Yeah? Can they react with oxygen? Yes, yes, yes. Well, do we need to burn them in every case for reacting with oxygen? Should we burn them? Because we are burning magnesium, correct? We are burning sulfur, we burn carbon, correct? Should we burn in every case? It's actually not necessary. For example, how many of you remember rusting, corrosion? Remember? Yes. What happens in rusting? Iron reacts with oxygen, correct? Are we burning it? No. It's a automated combustion, automated oxidation, right? Yeah. Copper, we don't need to burn it. It can automatically take up oxygen, correct? Right? So, the process of reaction with oxygen always need not be burning. In case if it is burning, you can call it as combustion, but always it is not burning. That's why we term it as oxidation. Oxidation is a process of addition of oxygen to either metals or non-metals. Okay, and this oxidation, you can burn them based on their reactivity. There are a few metals which are very active, like sodium, potassium. We don't need to burn and all, just expose them to atmosphere, they will get oxidized easily. But there are some metals like iron, they take a lot of time getting oxidized. And there are some more metals like gold, never ever they get oxidized, right? And we call it as what? We call it as metal reactivity series, correct? So according to metal reactivity series, the elements which are present above carbon are the ones which are reactive. They acquire oxygen all by their own. They are speedily reacting metals, right? And then between carbon and hydrogen, moderately reacting metals. After hydrogen, it is all slow reacting metals. Gold, platinum are examples of the metals which have very high stability and which do not react easily with any element, not only oxygen. They don't even react with other elements easily. They take a lot of time in reacting because they are very inert elements. I'm not saying inert gases, but they are inactive by nature, right? And there is one nickname also for those two elements, that is noble metals. Noble gases are helium, neon, krypton, xenon, rayon and all that. But noble metals are gold and platinum. Why noble metals? Because they are very inactive. They are very inactive. Right guys? Yes. So oxidation is a process of adding oxygen to anything. We all know about oxidation. Chapter 1. Remember types of chemical reactions. How many examples did we study? So many, right? Yeah. And you know what? Not you know what, let me ask you, have you seen oxidation of food materials? Oxidation of food materials, give me some 2-3 examples. Yeah, rancidity, that's a process, right? Okay, oil, chips, then bread mold. Bread mold is a contamination though. Turning off apple into brown. Once you cut the apple and expose the freshly cut layer to atmosphere, it gets oxidized, right? The iron present in apple gets oxidized, and that's why it will turn brown. How many of you have noticed it? Not only that, even banana gets oxidized, isn't it? Due to presence of minerals only. Sometimes there might be questions based on these things also. Yeah, apple, banana, why do they change their color? Yeah, that is due to the process of oxidation. Well guys, so we are talking about the same activity, that is oxidation. Oxidation always need not be burning. Burning or combustion is a type of oxidation, that's it. But oxidation is a huge process. It can happen in many ways. You can burn in presence of oxygen. You can use certain chemicals in order to add oxygen. Yeah, many ways of oxidation. There are many types of oxidation, of which one is burning in presence of oxygen. One is combustion, right? The second one could be oxidation with the help of chemicals like oxidizing agents, right? Yes, and you will be studying much about this oxidation with the help of chemicals in carbon and its compounds chapter. Okay? Yeah. So for now, remember 2 points. Oxidation is a huge process which has many types in it. Combustion or burning is a type of oxidation. Yeah, right? Metals do undergo oxidation. They need not only undergo burning and combustion, even you can add some chemicals, even you can leave them for free atmosphere, many ways. Are we all clear? Is there anyone who did not understand what I spoke so far? Is there anyone? No, right? If you are not able to understand, my dear students, please let me know. Yeah. Right, can silver react with gold? Gold, first of all, is very lazy, and silver is the third laziest element. They both know. And one more common point, it's a point of common sense, is two metals do not react. Two non-metals do not react. Yeah, it always happens between one metal and one non-metal. Two similar entities, two similar species do not react. Yeah. Well, now let's continue. We have taken just 1 or 2 examples of oxidation, right? One metal and one non-metal. So now what shall we do is, let us talk about oxidation of a few more metals. Okay, Are we ready? Oxidation of a few more metals. So we spoke about magnesium. Now let's continue. We already have an idea about oxidation of iron, oxidation of copper, isn't it? Yes. Now let me show you oxidation of sodium and potassium. Sodium and potassium, as we know, they are almost reactive elements. You don't need to give an initiation for sodium and potassium because they are active elements, isn't it? So as a result of this, what happens is once you start exposing them to atmosphere, they start acquiring oxygen from the atmosphere and this gets self-oxidized. As a result of this self-oxidation of such an active metals, huge quantities of energy will be released, and as a result of this huge quantity of energy release all at a time, what happens? It might look like an explosion, or it might just burst off the atmosphere or the surroundings. So in order to avoid that free oxidation, vigorous oxidation, Harshita, do you remember my lab situation? Yeah, the same way, where due to this vigorous oxidation, what happens? Huge quantity of energy is released, which could be destructive, so we should avoid it by placing sodium, potassium kind of stuff below the layers of oil or paraffin oil or kerosene. And this case, this kind of huge oxidation is applicable for non-metals also. We are comparatively studying metals and non-metals. In case of metals, sodium and potassium are dangerous, kept under oil to avoid oxidation. In case of non-metals also, there is something. Is there anyone who knows the name of that non-metal which is very explosively oxidative? You expose it to sunlight in presence of oxygen, that's it. It gets exploded. It's not bromine. I know, why did you say bromine? Because it would be fuming, right? But Papa, it's not explosive. Yeah, it just fumes. And bromine is very corrosive, very dangerous. If some bromine quantity spills in your palm this way, and if you can hold it for some time, it will just penetrate through all the tissues, cells, bone, muscles, and it will come out from the side. It is that corrosive. Very, very corrosive. So that's why we don't use bromine at the level of laboratory class 9 and 10, only after class 11. 11th and 12th also a few schools would not recommend bromine. It's very dangerous. Now, I did not get a correct answer for the non-metal, which is very, very reactive. That is phosphorus. Phosphorus is a non-metal which is available as two allotropes. One is white phosphorus and other one is red phosphorus. Okay, and as I told you, white phosphorus is used as rat poison. Red phosphorus is commonly used as a part of fireworks or manufacturing of matchsticks and all that. Yeah, so phosphorus, especially white phosphorus, it's a poison, that's true, but then other than that, it has one more peculiar characteristic, and that characteristic is it will catch fire easily. It's highly inflammable non-metal. If you expose that white phosphorus to sunlight, and if you can mediate this with a magnifying glass, within a few seconds to a few minutes of time, it catches fire and it starts to burn. Yeah, it's highly burning. And as a result of this, white phosphorus or phosphorus is commonly stored in oil or something. Where is it stored? It is stored in petrol, kerosene. I know you will answer these all. Kerosene, let me for some time enjoy your answers. I want everyone to be participative here. Why are you, a few of you are very quiet? Often I find the same people talking to me. How about rest of you? Paraffin wax, Jibin says. Dark bottle. Right? A liquid, paraffin wax. But then this phosphorus is stored in water, because the condition with phosphorus is it should not catch that heat, isn't it? Until and unless it is not catching that heat, it does not start to burn, because it is inflammable. It has a very less ignition temperature. You don't need to protect phosphorus from oxygen, but you have to protect it from temperature. So what do we do is we place it under water so that it doesn't get exposed to heat easily. And even if somehow it is getting exposed to heat, because water is there, it cannot catch fire. Water is a suppressor. I mean, it suppresses flame, isn't it? Yeah, fire suppressor, correct? So we save it under water because of two reasons. One, it should be protected from heat, not from oxygen. Two, if it has to be protected from heat, if you can store phosphorus under the layers of water, even if there is a scope that atmospheric temperature increased or accidentally something happened, the water here acts as a fire suppressor and it will prevent from explosion being caused. Yeah, right. So sodium and potassium are highly active metals which can get easily oxidized in presence of atmospheric moisture and oxygen. The reaction is explosive, so we have to place them under oil like kerosene or paraffin oil. Yeah, and non-metals such as phosphorus is again highly reactive with oxygen provided it reaches ignition temperature, and as a result of this we have to protect phosphorus majorly from heat, so we place it under water, and as we place it under water the chances of phosphorus catching fire reduces drastically, so it is safe enough, right? Are we all clear? Are we all clear? And now if you get a doubt, why can we not store either potassium or sodium in water? My dear bright students, please think of one point. Water has what? Dissolved oxygen. And you're trying to save sodium and potassium from oxygen only. Secondly, water itself is an enemy to the metals, right? Yeah, water to potassium and sodium is just like an enemy. The moment you add it, it's gone. I was having some video or GIF kind of thing for the reaction. If it is there, I'll definitely show you now how spontaneous that reaction is. Give me a few seconds. I'll just take off that GIF. Okay. And one more thing, we spoke about sodium and potassium, not only sodium and potassium, but of course other metals of first group like cesium, rubidium, they are also explosively reactive. We are talking about sodium, potassium because we are familiar to those two elements. When you go to class 11 and 12, you get to study about reactivity of the entire periodic table. That's when you realize, the most explosive reaction between a metal and water is of cesium. Okay, I'll show you. Give me a few seconds. Well, it was there on my desktop, but I'm not sure if it is there right now. But if it is there, definitely. Okay, it's not there on the desktop, but I can just open it from the internet. Yeah, well, take a look at this, guys. I'm now showing you the reaction between the metal cesium and water. Are we all ready? Are we all ready? Yes, right. Take a look. You see the GIF? Do you see it? How fast is the reaction? Don't you see? Do you see it now? Is it getting loaded or something? Do you all see it? It is that fast. This is about cesium. Cesium, the most reacting metal. The most reacting metal is cesium. Now that we are talking about metals like sodium and potassium, the reaction would be very, very similar to what you have seen right now. But of course, the reaction could be expected to be a little more slower than what you have seen. Okay? Yeah, this is how explosion happens. This is how it happens. Right, guys? That's why we should not get water in touch with the metals of first group. The metals of first group are the most reactive elements. Okay? Yeah, shall we go ahead then? Right? And now, we spoke about very, very reactive metals. Now, let's talk about the metals which are moderate. Okay? The moderate metals like iron, aluminium, sometimes magnesium also can be considered as a moderate reactive element. Yeah. So these elements, they react with oxygen. They slowly react. They are very sober. The reaction between such metals and oxygen, such metals and water is very, very sober. Very sober as in rusting. Have you ever seen explosions, blastings and all happening while iron is rusting? Have you ever seen? No, right? And what about this? What about rusting of copper or corrosion of copper? Reaction of copper with atmospheric gases. Even copper undergoes corrosion, right? A dirty green color layer will be formed, right? Actually, people say dirty, even that's a beautiful green. Yeah, correct. So that green is caused due to oxidation of copper, right? Copper turns into copper carbonate and copper hydroxide. Is that explosive? No, that is also not. Aluminium utensils that we use in kitchen, when we buy, they'll be damn shiny. Nothing will withstand them. But then as the time passes, they start losing their what do you call it as luster, right? And then ultimately they acquire a grayish black colored layer over it, right? So that is also oxidation. Aluminium, which is present in the atmosphere, which is present in the utensils, is reacting with the atmospheric oxygen. As a result of this, what's happening? As the time passes, aluminium slowly combines with atmospheric moisture as well, and it leads to formation of aluminium oxide, Al2O3. Is that explosive? No. They are also metals. They are also reacting with oxygen. They are also being exposed to water. Don't we wash aluminium vessels, aluminium utensils of kitchen? We wash it every day, right? Are they getting exploded the way you have seen? No, because they are moderately reactive metals, correct? So all the metals undergo oxidation except noble metals. But a few metals oxidation is explosive because they are too much reactive. And a few metals are very slow and sober. They are also reactive but moderately. There are a few metals like our noble metals, you do whatever you want, they don't respond. That's why we call them as noble. Yeah, gold and gold and platinum are best examples. This is about oxidation of metals and oxidation of non-metals. Well, since we are talking about oxidation of non-metals also, I'll give you some more common examples. How many of you have seen burning of coal, charcoal? Of course, you might have seen it in the iron box or that old fashioned. We give clothes to get ironed outside, right? Not in home. Then the person, the iron man, will be using the charcoal bases. He'll lighten them, and with the heat produced, he'll do this. Correct? And even these days, charcoal is used as a source of energy in order to produce electricity. Correct? Barbecue, yes, that's a good example. That is all nothing but burning of carbon. What do these all things contain? Charcoal, coal, coke, these all are nothing but carbon, right? So you are burning carbon in presence of oxygen. So can we not call it as burning of non-metal? It is burning of non-metal, correct? Yes. And burning of non-metals is not an explosion reaction unless and until you are talking about phosphorus. Okay. And there are some non-metals on burning, they create beautiful colors. You know, crackers, fireworks, they do contain metals and non-metals only, right? They have sulfur, they have phosphorus, they are non-metals obviously, right? And other than that, there are metals also, such as, of course, magnesium, which gives a white dazzling flame. It has barium, many more metals. Based on the metal used, the color is acquired, right? So about this topic, we'll talk in the uses, okay? Uses of metals and non-metals. Now let me quickly come back and summarize what I said. We are talking about oxidation of metals and non-metals, the first chemical property. Oxidation of metals, if it is active metal, explosive and vigorous, releases a lot of heat like cesium, sodium, potassium. If it is medium reacting metals, it's very slow, no huge heat released. And then noble metals doesn't respond. Non-metals, phosphorus is the one which is vigorously reacting, but rest of the non-metals, they burn in presence of oxygen. They lead to formation of non-metallic oxides. Non-metallic oxides are acids by nature. Metallic oxides are basic by nature. MB, remember? Right. So this is all about oxidation. Right, guys? Now, let me take a pause. Is there anyone who did not follow it or anyone who has a doubt? Please post your doubt only once. I know you guys are very decent. You will do it only once. I really like your batch. You know, very responsible batch. So post your questions, guys. Do you have any questions for me from this particular topic? Phosphorus is used for doing anything. What are you saying? Phosphorus is the one which is there in the crackers, fireworks. It is there in the matchsticks. It is used in manufacturing of bombs, explosives. Other than that, poison also. Yeah? Well, what about mercury? Mercury is a liquid metal and it has least reactivity. It falls into the category of least reactive metals. It comes after hydrogen. Remember that metal reactivity series shortcut? Stop calling, please stop calling me a careless zebra. Yeah, in that it all falls after hydrogen. What? Copper, mercury, silver, gold, platinum. Because it's slowly reactive, it takes a lot of time to combine with oxygen. The reaction is not explosive at all. It does not release heat and all. Yeah. And then one more thing, mercuric oxide, the metallic oxide of mercury. Mercury is a liquid which has a little lustre, little shine, right? Mercuric oxide is a powder. It's an amorphous powder which has a reddish brown color. You have seen bromine's color, right? The powder of mercuric oxide will have a similar color. It's very beautiful to see. You will see it in your laboratory also. If possible, try it once. Yeah. Next, why gold do not react with oxygen? Gold not only with oxygen, my dear, it doesn't react with anything because it is a heavy metal. Its atomic mass is very, very heavy, and generally heavy metals are very lazy to react. Well, amphoteric, we are coming. Hold on for 1 second. Okay, not 1 second, hold on for 1 minute. Pavitra, you have a chemistry test on Friday. All the best. And reach me if you want any help, any doubts or anything. Okay. Well, reaction of SO2 with H2O. That's a good question. I did not mention that. Yeah. So, well, let me write it here. When we are, you see the screen, right? Let me take a white page. We have studied that a magnesium oxide or sulfur dioxide are being added to water and it leads to formation of a solution. I'll write the chemical formula of the solution. When it is magnesium oxide and we are adding it to water, leads to formation of magnesium hydroxide. Presence of hydroxide determines the molecule to be basic. That's why it is basic. And H2O, if it is added to SO2, lead to formation of H2SO3. Sulfurous acid. Remember guys, it is sulfurous acid. It's an acid, so the color changing litmus occurs. Well, then Harshit says all clear, that's good. Anushka, in what cesium is stored? Oil. It is stored in the oils. Majorly the oils which we prefer are kerosene or paraffin oil. We don't prefer petrol and all because petrol is inflammable, right? By mistake, if something happens, petrol just takes the reaction to next step. If it is paraffin oil or kerosene oil, they are not inflammable. Yeah, they catch fire, but then not as easily as petrol can cause, right? So we take kerosene or paraffin oil. Then, next one. Are there any noble non-metal? Non-metals, they are almost reactive. Well, can phosphorus be kept in fridge? You can keep it in fridge, but then it's always to keep phosphorus underwater and then freeze it if needed. Does the same reaction occur when we burn carbon or charcoal? If you are talking about Zubin, first of all, I'm not clear, is this a continuation of some doubt or whatever, but then I'll write the reaction here, okay? Whenever we are burning carbon or charcoal, if it is charcoal or coal or just anything else like coke or coal gas or whatever, it's altogether carbon, just carbon. And when you burn carbon in presence of oxygen, the product is CO2. Let it be charcoal or bone charcoal or activated charcoal or coal gas or coke, everything has carbon itself, right? This is the reaction, one and only reaction for everything. And in all these items that I have listed, the percentage of carbon will be increasing or decreasing. That's what is the difference. A few substances will have 90% carbon, 10% impurity like coke. But there are a few substances which will have some 50% carbon, 50% impurity. It gives a lot of smoke and fume. Yeah, depends upon purity. Now, next question. Gold is intellectually lazy. That's a right comparison, Harshit. Well. Next one, H2SO3, Sneha, good. You have given the molecular formula of sulfurous acid, very good. Sulfurous acid, Pavitra also has said. German silver does not contain silver. First of all, German silver, it's a metal. It's a mixture. It's not a metal. It's an alloy. It has a combination of different items. And you know what the twist is? It doesn't have any silver. German silver looks like, the lustre of German silver looks like silvers. So we commonly call it as German silver. That's it. It doesn't have any silver. It's an alloy. Okay. Well, next question. Rusting, yeah, rusting is a slang term used for iron's corrosion. The technical word is corrosion. Next one. What happens to mercury if it reacts with oxygen? Nothing happens. It will react and it will turn into a powder. You know how to react mercury? Just take it in test tube, heat it, or burn it to some extent. It will easily only react. It's not as stubborn as gold, platinum, mercury. I mean, gold, platinum are. Yeah. Well, does the same reaction? I think it's been addressed. Is cesium a rare metal? No, no, no. It's not a rare metal. Product of oxidation of phosphorus. Phosphorus P2O5. Phosphorus pentoxide. Then sodium. Why sodium catches fire? Oh my god, someone asking me this doubt. Guys, why does sodium catch fire? If you just place it openly without placing it in the oil or whatever. Anyone who can answer this question, I'm going to unmute you. Anyone? Harshita, your chance is over. Who can? Well, Yashika. Yashika is the one who responded after Harshita. So let me go to Yashika now. Okay. Well, my dear student, whoever have asked me this doubt, please listen to Yashika carefully. If your doubt is clear, that's fine. If not, I'll explain you again. Yashika, can you please talk?
Yeah, good evening, ma'am.
Very good evening, Yashika.
So yeah, basically, metals like sodium, potassium, helium, and cesium have low melting points. Therefore, they burn easily when exposed to atmospheric oxygen,
Oxygen only or moisture also?
moisture also, atmospheric air.
Yeah, atmosphere which has oxygen and moisture. Sodium and potassium, they have low ignition temperature, yeah, and they
Yeah,
are very reactive. They easily react with oxygen. They have high affinity towards it. As a result of it, a little exposure to oxygen or moisture, they start reacting and the reaction is very, very explosive. So they release a lot of heat, which is very
highly
dangerous.
reactive.
Right, thank you so much, Yashika. Thank you. And I hope, my dear, whoever asked me this doubt is now clear, right? Well, now, guys, there were some doubts which I could not address or which I did not address. Now it's time for those doubts which are missed. Please repost it only once for me, only one more time, and make sure you ask me doubts related to this topic. Okay? And please don't ask me if something is metal, something is non-metal. Did I share the periodic table with you, which has the list of all metals, all non-metals, and all metalloids? Did I share it? Yes, right? Yes. So now you got to verify from there. Please do not ask such funny questions, right? Well, very good question from Rohan. Actually, we spoke that cesium is a very, very reactive metal. But there is something else which could be more reactive than cesium, and that is francium. But unfortunately, francium is a radioactive metal. Radioactive in the sense it's never stable. It starts killing itself. It starts decomposing its own nucleus. If you place 100 grams of francium in a place, come after a while, out of 100 grams, a little quantity would have been gone. It would just have been decomposed, degraded. So that's why, because it is unstable, we don't consider francium or we don't consider radioactive metals for the study of reactivity and all that. Right, Rohan? That's a good question, dear. Keep it up. Does the metal react with base to give salt? Pavitra. Okay, medium kind of question, but listen to the concept. Everyone, not only she, everyone. No similar species will react with each other. Okay, so now I said that the nature of metals or metallic oxides is what? The nature of metallic oxides is basic, correct? And you already have a base. How can you expect a base to react with another base to give salt and water? It's not possible, right? Is it possible? It's never possible. That's why metals do not react with bases because they are already basic by nature. They already have that basic behavior, right, Pavitra? Then sulfuric acid should be, hey, Yashika, that was sulfurous acid. Sulfuric acid is H2SO4. When you dissolve SO2 into water, it is sulfurous acid. Guys, the reason I give you a lot of time for your doubts is you should understand everything that's been taught in the class perfectly. That's when your learning is complete. If you understand half and half, you go read the textbook, you will have that incomplete way of learning. So you have any doubt related to the topic, please ask. Yeah. Well, solution of metal oxides. About conductivity. That's a good question though, but we are going to talk about it in a while. Yeah. Well. Double displacement, my dear, not now. Yeah. Please talk at the end of the session because first chapter, na? Right. Well, that's it, guys. I hope almost all the doubts have been noticed. Almost all the doubts have been addressed. Well, what shall we do now is let us get ahead. Yeah, let us continue the same activity. There are 2-3 more points that you should know. After that, let me take a pause one more time. Yeah, ready? Yes. Yes. Very good. Very good. Very good. Right. Poonam, what is reduction? What a question. Did you study chapter 1? Yeah? Types of chemical reactions, oxidation, reduction, redox. It is that, right? Refer it from that chapter. Otherwise, please stay till the end of the chapter. I'll only explain one more time. Right, guys? So we spoke about the behavior called as acidic, basic, and neutral, amphoteric when we were talking about acids and bases, right? Even the oxides of metals are bases by nature. The oxides of non-metals are acids by nature. But there are certain such metals whose oxides are not purely basic. They are at a middle point, they are at a sector where they tend to exhibit both acidic and basic behaviors. For example, if you take oxides which are caused by zinc and aluminium, you see it on the screen, right? When you take the metals such as zinc or aluminium and when you oxidize them, as a result of that, they form aluminium and zinc oxides respectively. And these aluminium and zinc oxides, basically, they are not bases, they are amphoteric. The reason behind this is aluminium and zinc, they fall into moderately reactive series, isn't it? And because they fall into very close by place to least reactive metals, in spite of being strongly basic, they tend to behave both acidic and basic. They are just like metalloids. Yeah. So not all the bases, not all the metallic oxides are bases, but there are certain metals whose oxides are amphoteric. What is definition of amphoteric? Amphoteric are the ones which exhibit both acidic and basic behavior. Remember, water is amphoteric by nature, correct? Water has both H plus OH minus. Very good, Adrita, right? Yes, the same way, the oxides of metals such as zinc and aluminium are also amphoteric because they react with both metals and non-metals. Yeah. And what is the molecular formula of aluminium oxide? Anyone in the class? Aluminium oxide is? Good. Very good. Aluminium oxide is Al2O3. And what is the oxide of zinc? Zinc oxide is ZnO. Very good. Now, I said aluminium oxide is amphoteric. We need a proof, right? In chemistry, for everything, there needs to be a proof. Take a look at this. Aluminium oxide, when you treat it with acid, it gives a product. Okay, it is a base. You have treated with acid, it has given you product like salt and water. Perfect. Now, observe the second case. The same aluminium oxide, if you react with base, even then it will react, leads to formation of a salt and water. What does it mean? If it was a pure base, would it have reacted with another base? It's not possible, right? That means aluminium oxide is not a pure base. It's not a perfect base. It is an amphoteric molecule. The same is the case with zinc oxide. Zinc oxide can react with HCl to give zinc chloride. And it will also react with NaOH to give sodium zincate. Yeah. Well, so it is proving that aluminium oxide and zinc oxide are amphoteric by nature, correct? So this is all about only one activity. You know, we have studied only one activity so far. But then since we have studied extensively about it, this will greatly help you when you go ahead with the next activities. Yeah. Well, so now, are you not able to see me? Is there anyone who is not able to find me? I mean, who is not able to see my webcam video? Okay, there are a few students. What I'll do is I'll quickly refresh. You will be able to just listen to me now for 5 seconds. I'm just refreshing the webcam. Yeah? Are you able to see me now? Am I visible now? Yes, that's good. So now let's continue with the chemical properties of metals and non-metals. Let us take one step ahead. I hope whatever is happening in the class so far, whatever we have discussed, you are able to understand. But then for my satisfaction, let me know through this poll. Very good, very good. Sneha, I think this point has been discussed. My dear students, please be attentive when I'm speaking so that you can avoid a lot of repeated questions, right? Yeah? And that will save a lot of time of us. Okay, Harshit says that this poll question is a 20 marks board question, it seems. Well, right. Most of you say that they are following, but still I have, I guess, 3 students in the class who are finding it difficult. So please let me understand through the chat box that what is your difficulty. Yes, guys. So now I'm going to the next chemical property, and once we are done with next chemical property, probably in 5 to 7 minutes of time, I'm coming back to doubt session. So any of your doubts, hold them, yeah, keep them with you for 5 more minutes. I'm coming back, right? So there you go with activity. The next activity, let's not go over the number, but let us go over the reactive, I mean the procedure or whatever reactivity that they are talking about. Okay, yes, right. So what are they saying now is put small pieces of the samples of what, metals, in different beakers which are consisting of considerable quantity of water. I did not say yes from every one of you. Shall we go ahead? Is that okay to hold your doubts for 7 minutes? Is that okay? Yeah? Right. So I'm coming back. Hold on. Well, guys, so we are taking a few metals, the samples of few metals, and we are placing them in different beakers. Look at this carefully. This point also we have discussed, but it has come up as an activity now. Yeah, you have taken some beakers and then you have placed them underwater. Maybe say you have taken magnesium, you have taken some zinc, and you have taken some sodium also. Would you expect the same reaction from all the 3 metallic samples that you have taken under cold water? What might happen? Magnesium and zinc would be fine, but then what happens to sodium and potassium? They also get oxidized, no doubt about it. They'll form oxides, but then they release huge quantities of heat. Yeah, we have seen the GIF of cesium, correct? The similar way, potassium and sodium also look like. Look at the reaction. The chemical reaction, potassium and water, they combine with each other, leading to formation of potassium hydroxide and hydrogen gas is released. You know what is the add-on for this explosion? First of all, huge heat is released. Okay, keep it on one side. Upon that, there is hydrogen also released. And we know the nature of hydrogen, right? It is inflammable. It catches fire like anything, correct? So for that heat energy and presence of hydrogen all together, which cause the explosion more vigorous. Yeah, the 2 reasons behind explosive reaction of metals like potassium and sodium with water: one, release of huge heat energy; the second one is liberation of H2, which in turn reacts, which in turn catches fire and burns with a vigorous nature, right? Yes, are we done with this already? We spoke, right, how to store these things, correct? I want you to acknowledge. Yes, only Adrita said yes. How about others? I want to see. Yeah, very good, very good. Guys, be responsive. Let's not, make it so mechanical. Like, I'm just looking at the screen, you're looking at the screen. We find sleepy after a while, correct? Talk to me. Yes, guys. Now, going to one more metal. We spoke about sodium, potassium with water. Calcium with water. The reaction is not so dangerous and all. It reacts slowly. It does not release huge quantities of heat and light, but then it releases hydrogen, which comes out in form of bubbles. And after some time, what happens is this calcium slowly gets consumed and slowly it starts to form calcium hydroxide, isn't it? and there will be hydrogen bubbles being produced, which makes the density of calcium lesser. And as the time passes, the calcium starts to float in the water. This is important point. There are frequently found questions related to this point. Yeah, calcium starts floating after a while because the bubbles of hydrogen gas are formed, and they stick on the surface of the calcium, and they bring the calcium sample up to the top layers of water. This is what is the observation when we add a chunk of calcium to water, right? Remember this, make a note of these points. Sodium, potassium, vigorous reaction, explosion. Calcium, it will just start floating after a while due to, of course, due to release of hydrogen, and because the bubbles of hydrogen stick to the surface of calcium, right guys? Now let us get ahead. Take a look. We are now talking about magnesium. If you take magnesium, if you drop a piece of magnesium into water, okay, if it is cold water, believe me, nothing happens. Magnesium will remain as it is. If it is a little hot water, that's when it starts to react slowly. Because you remember, sodium, potassium comes, and then comes sodium. After that is calcium, and then comes magnesium, right? So the reactivity goes on reducing. So magnesium is not very much reactive. Sodium, potassium with cold water itself, they are like heroes. Coming to magnesium, cold water cannot affect. So you need to add hot water. That's when it reacts, leads to formation of magnesium hydroxide. Yeah. After a while, magnesium also starts floating. Again, same reason, hydrogen bubbles are formed. And remember this point also, hot water point. Magnesium reacts only with hot water, not with cold water. Why? This is a board question. Yeah. Right guys, are we going clear? Is there anyone who is not able to follow? Is there anyone? I'm not spending much time on each slide because we have had a discussion of the theory, right? Now we are just looking at the equations. Now let's go to the remaining elements. Aluminium, zinc and iron. Aluminium, zinc and iron, after this reactivity series, they come, right? Aluminium, and then is zinc, and then is iron, correct? Of course, plumbum also comes. We have not taken it because we don't get that in our syllabus frequently. What is the case? They are still having less reactivity. Even warm water cannot affect them. You have to pass steam over their surface. Only then they will respond. You add cold water, you add hot water, warm water, nothing happens. It has to be steam. What is the temperature of steam? Estimated temperature of steam is? It is very close to the boiling point of water, correct? It is very, very close to the boiling point of water. The particles of steam are highly energetic, correct? You have to use that high temperature to react with aluminium, zinc and iron. That's when they'll react. And even then you see, they'll just form oxides. If you have observed, the metals like magnesium, the metals like, where is it gone, calcium, they were forming hydroxides. But aluminium, zinc and iron, they just form oxide. This is the order. If there is a metal, first it should form metal oxide and then is metal hydroxide. Okay. Now active metals directly jump into the third grade. They skip this, but these metals are very slow like a tortoise and they go step by step. Yeah. Are we clear? Are we clear? Yes? Right. Now let's get on with the next slide, where we are going to talk about the overall summary of whatever we have done so far. We spoke about oxidation of metals in presence of atmospheric oxygen, burning or combustion, and then we spoke about activity of metals with water. Actively reacting metals react with cold water, moderately reacting metals hot water, and a little slightly less reactive metals like aluminium, zinc are the ones which react with steam. Because the steam has high energy, only at that high energy they become reactive. Right guys? This is about chemical properties of metals. About non-metals reacting with water, let's talk later. Why later? Let me tell you now only. Commonly non-metals do not react with water. They have very, very least reactivity with water. Okay? You take carbon, put it in water and see what happens. Nothing happens. Phosphorus, we protect it in water, correct? Sulfur, nothing happens, correct? Commonly, non-metals do not react. There are exceptions, and those exceptions will be discussed as the time passes in the later sessions, yeah? But for now, remember, water has a very, very less effect on non-metals, right? Yes? Well then, now what I shall do is I'll take you to the textbook. Take a look at this. The reason I take you to the textbook in every class is, believe me, NCERT is like a god book for your board exams. The very first step, the very first source that you should be perfect at is NCERT. Every line, every activity, every question is important. You know how many brilliant teachers, how many brilliant experts will be involved in writing this book. And you must be knowing this, right? NCERT is one of the best resource for science in the world, not in India all alone. It matches up standards with the international boards as well. With respect to the, what to say, with respect to the way it helps you understand concepts. It all is practical based, right? Understand its importance. Is there anyone who is preparing for competitives, JE, NEET, Olympiads, NTSC? Is there anyone? If you are doing so, you are the ones who have to be 2 steps ahead than other students. NCERT, there should be a print of NCERT. If I ask you in NCERT, what is written about potassium in the chapter metals and non-metals, you should be able to tell. You should be that thorough. Yeah. So take it serious. Be very, very clear with NCERT. I'm telling you again and again. You want to follow reference books? Very well follow. But do that only when you are done with NCERT. Right? Yes. So now coming back, this is all 3.7 we have done in the last class. 3.8, magnesium ripple, sulfur, burning. Correct? Starts chemical properties. What happens when metals are burnt in air? Do we know it? Yeah. When you take metals like magnesium, burn it, you will get oxides. And those metal plus oxygen is nothing but metallic oxide, right? And of course, you don't need to burn every metal. The metals such as aluminum, magnesium, iron, copper, they just get oxidized as usual. And oxides are commonly basic. Aluminum and zinc oxides are amphibolic. And then, what happens when metals react with water? Do we know? Yes, a few metals behave like villains, but a few metals are sober. Correct? Yes. Now, look at these schematic equations. Metal plus water giving metallic oxide, metal plus oxide plus water, metallic hydroxide. Did we do this? And then we have added a litmus to check the nature. Correct? The same schematic equations. And one more thing, carefully observe this image. When we were talking about reaction of metals with water, certain metals like aluminum, zinc, I said that they react only with steam. But then steam is a vapor, and if you effectively want the metal to react with steam, this is the equipment. Yeah. So here is the steam, here is the glass bowl, and there is the metal. You are heating so that the water, okay, I can't draw anything here, so that the water which is suspended in this glass bowl would slowly get evaporated and steam is produced. The steam produced slowly comes in contact with the metal strip and it oxidizes. Yeah. And as a result of this oxidation, metal oxide and hydrogen are formed. Remember the equations? Metal oxide and hydrogen are formed. Let me take you back. Yeah. Do you see this hydrogen being formed? The hydrogen, if you want to check if it is hydrogen or not, pass it into a jar, collect it, and then test it with a burning splinter. You will find a pop sound. Correct? That is the activity about. Is there anyone who did not understand this image? Often students find this image to be a little weird. It's a different kind of apparatus, right? That's why. Everyone clear? Everyone? Yes. Yes, that's good. That's good. And these equations, all we know, say carbon, calcium with water, aluminum with water, we all have seen it in the wave book itself. Correct? Yes. And then that's all what we have done till now. Next, we are going to talk about metals with acids. But before I could do that, what is the time now? Yes, before I could do that, a gap of some 2 minutes. Do you have any doubts so far in the two chemical properties we discussed? And don't think that in 1 hour, 10 minutes of time, we just discussed the two chemical properties. Guys, we parallelly have completed non-metals also, right? Yes? Yeah? So don't worry about it. Don't worry about the time. What matters is till which extent have you learned it perfectly. Okay? Right? That's good. That's good. Well, now if you have any doubts, please put across your doubts here. I think I missed a few of doubts. I'm scrolling back. We have completed till page number 43. Good, good. What is the anodizing box in the textbook? Anodizing, as we still have not covered anodizing, don't worry about it. There are certain such principles and terms which we'll be covering all together in the uses of metals. But still, since you asked me, I'll just take you to that page and I'll explain you in brief. Okay? Not only he, rest of you also can listen. Anodizing is an important process. Let me take you to the page. Well, okay, I'm not sure if I'll be able to open the page, but still, let me just orally explain. Alright, no, it's okay. I'll explain you a few important terms. Okay, so there are a few terms such as anodizing, galvanizing, which would be confusing with each other. Remember, galvanizing is an anti-rusting technique, isn't it? Galvanizing is a procedure where we will be applying some anti-rusting metal over the surface of a rusting metal, correct? And that anti-rusting metal is commonly zinc, and that is called as galvanizing. Anodizing is something which rhymes. I'll show you the image of anodizing first, okay? And anodizing is a procedure. Do you all see one image on the screen now? Do you see any image? Is some image visible? Yes? No? Are you not able to see anything on the screen? Okay, fine. Don't worry. 1 second. Right. Are you able to see something now? The color metallic strips. Do you see something? Oh my God, not even now. Yes, right. Okay. Have you ever seen this kind of colored surfaces of metallic articles? You know, they will be just colored so beautifully. Yeah, they'll be having a dazzling shine, correct? So that process is nothing but deposition of an oxide layer of a metal over any metal. It is nothing but a thin layer of oxide of metal at the top. And this anodizing process commonly is seen in the metals such as aluminium. Because of this formation of a thin layer of oxide of aluminium at the top, the bottom layers of aluminium are damn protected. They don't get oxidized anymore. And this anodizing is a natural process and it is a slow process. Of course, you can fasten it with the help of electricity as well. Yeah, anodizing is a process where the top layer of metal gets oxidized and then it will form a protective layer for the inner molecules of metal. This is anodizing. That is galvanizing, right? And there is one more time called as tarnishing. Tarnishing is also something like this only. But then this happens especially when we react metals with nitric acid. Remember this term, tarnishing, T-A-R-N-I-S-H, tarnish. Yeah. When you add concentrated nitric acid to certain metals like silver, the top layer reacts. It forms oxygen. But then the protective layer of oxide of metal will not let nitric acid to go react with the inner layers. It acts as a screen between the outer oxygen and inner metals, right? Are we clear? Is there anyone who did not understand? Is there anyone? I'm talking about only this. Everyone have understood, right? Yes, that's good. Now what shall we do is I'll quickly take you back and I'll scroll the chat box because I know most of you have asked questions. Someone who is preparing for KVPY, good luck. You will have less resources for KVPY. Concentrate, prepare well and clear it. Aluminium, not a noble metal, dear. It's a slow reacting metal. I told you, right? Noble metals are the ones which fall at the bottom of the reactivity series. Aluminium is in the middle. Activity equipment, Harshita. Which activity equipment? That steam burning of, creating steam by heating the wire gauze soaked in water and reacting metal strip. Is that what? You can get this equipment, okay? Someone in the group also have asked me. But you know what? You, as a student, if you go want to buy, you will not be able to get. You should have one of your teacher or something. You can ask your teachers to conduct practicals like this also in the school. You can request your principal or something. Yeah. Then zinc. Okay, this is answer for what I have asked in the galvanization. Okay. Why don't I say, they ask to write steps for activity. If they ask, can we write our own words using Jan Prakash? Yes, not only Jan Prakash, rest of you listen. Whenever they are asking you to explain something, describe something. It's not necessary you have to mug it up, by heart it and write as it is. You can always write it in your own words. But remember one point, you should use the same scientific terminology. There's a difference in talking science and talking English, right? English is a general language, it's a communicative language, but science has its own language, right? Make sure you use the scientific terms, correct? Then, next. Francium at room temperature, unstable. Is water is there in that tube? I know you're talking about the steam activity. Water is there in the glass. You remember? I'll show you the image if needed. Quickly. You see the wire gauze here? Wire gauze which is soaked in water. So this has water, right? Hope that's clear. Then next one. Okay, there's a doubt from Eshika. Calcium plus water, calcium hydroxide. Calcium plus water, calcium hydroxide. What is the doubt? What is the difference? I did not get. CaOH twice. I get it. Yashika, you are talking about calcium with water, calcium oxide with water. That's a good doubt. 1 second, I'll take you back. Where are we? Okay, Yashika has a doubt asking that in the first chapter we have studied when calcium is reacting with water, it leads to formation of calcium hydroxide. Yeah, but here we also have studied that calcium oxide can react and give calcium hydroxide. You see this calcium, the reaction of calcium with water is less violent. It also depends upon the temperature of water as well. If calcium is extremely reacting or reacting with excess of water, it leads to formation of calcium hydroxide immediately. If not, if it is reacting with limited quantities, it will form calcium oxide. And even if you have calcium oxide as a main source, even if you add water, it leads to formation of calcium hydroxide only. Both are correct. Yeah, you have to use this reaction based on the circumstance, based on what the question is. Yeah, right. Now, my dear students, sodium hydrogen acetic. Okay, who is this asking? Ismail, I think we are talking about acids and bases, and you are asking me a question which is directly from either NCERT or textbook or wherever. Listen one thing, my dear students. You know what? Whenever you ask me a doubt, make sure it's a doubt generated in your head. Don't ask the questions which are asked in assignments or tests or in some other book. You know what happens if you do that? You will lose your independent way of thinking. Whenever you come across a question, think in infinity ways. Come up with your opinions. You ask me, why is it this? Why is it not that? I thought it could be that. That's a doubt. You can't ask a question to a teacher directly from, okay, I'm solving an assignment. What is the answer for this? You know, that's not a right way, right? So try answering. You go wrong, no problem. You go wrong, but then you will think, right? That's what is important in studies, right? Yeah? Right. That's good. Now, guys, I would like to ask you a few questions. It's been a long time that I did not launch any poll. Are you all ready for the questions? Yes. I have some very simple questions to ask you. Are you all ready? Well, if you are ready, there we go with the first question on the screen. First question on the screen. Well, you'll be able to see it in few seconds. I still did not open the screen. Now it's open. Do you see it? When a metal reacts with oxygen and the oxide form is dissolved in water, it forms a... Go through the options. Be ready with the correct option. I'm not going to read out the options, okay? Because I just want to ensure you guys read the options thoroughly. Most of you have done it correct, but guys, let me tell you something. What did I tell you to remember? MB, right? Very good, very good. Oh my God, I already have some 10-15 students saying MB in the chat box. Good. What is MB? M for metal oxide, B for basic. But then I have students who did not remember this and who have marked it to be acid or neutral, I mean salt. Yeah, the correct answer for B should be basic. It has to be option B. MB. At least now remember. Yeah, at least now remember. Right. Sahil, yeah, you can remember this with the help of any trick which you are comfortable with. Yeah. Now, ready for the next question? Yes, ready for the next question? Right, then that's good. We are going to see the next question. The next question is on the screen right now. One second, it will be. You will be able to see it now, right now. Okay, go through the question. This time, go through the options as well. Everyone able to see, I guess. And once you're ready, let me know. This question, yeah, you have to think a little. When copper oxides react with dry hydrogen, copper oxide with dry hydrogen leads to formation of. Ready? You know this question, to answer this question, you need a little knowledge of first chapter also. Oxidation, reduction, redox. You need to apply the knowledge of that as well. Yeah. I'm not going to reveal the answer. I see people answering. Anishka, Rohit, Sahil. Think of your answer one more time. Read the question once more. Write the symbols, write the chemical equation, and that's when conclude the answer. Yeah? Sneha, again, verify. Anishka, Aditya, verify. Rohan, good. Adrita, good. Rohit, verify one more time. Devender, good. Rahi, verify. The question is, copper oxide, CuO, reacts with hydrogen, dry hydrogen. Apply metal reactivity series. What will happen if you apply metal reactivity series? You will get to know which is more reactive, correct? So copper, is it more reactive than hydrogen? It is less than hydrogen, isn't it? Yeah? Copper is less reactive than hydrogen, correct? So what happens? Hydrogen comes and takes away oxygen, leads to formation of H2O and copper. It gives copper all alone. Remember this reaction? It's an example of redox reaction. CuO plus H2 leads to formation of Cu plus H2O. Copper gave you a reduction. H2 got oxidized. Remember, there is no special boundary between first chapter, second chapter, third chapter. The questions in your board exams will be like this only. They are bridge questions. These topics are interrelated. Yeah. So always, whenever you study one chapter, relate it to the chapters which you have studied before this. Like now you are talking about reactivity of oxygens and all, related to displacements, related to oxidation reduction. Yeah. Right. That's how you should study. Correct? Yes, guys. Well, now let's go on. Have one more question, and that one more question, it's not done yet. Let me see if I have another question which falls into the syllabus which we covered in today's class. This is also not done. There is a question now. Take a look. Metal oxide, which is acidic as well as basic in nature, is called as. Do you all see the question? You see it, right? Okay, I will see who will be answering wrong to this question. I'll make note of your names. I'm waiting. Okay, I see correct answers from all of you so far. Very good, very good, very good. Is the question visible? Do you all see the question still? You see it, right? Very good, 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 very good. No one caught so far. I'm still waiting. If not, listen to me carefully. There are two metals importantly. One is zinc, other one is aluminium. They give amphoteric oxides. Amphoteric oxides are the ones which have both acidic and basic behavior. Yes? Clear? Right? That's good. That's good. So don't get confused. These are the important points from where 1 mark questions could be seen. Okay? Yes? Now, I have one more question, and that one more question is again based on first chapter. Okay? Observe. Go through the question, go through the options and be ready. You can't see? I think you should be able to see. You are able to see, right? Good. That's good. With the help of this question, I will clearly understand how many of you are really studying chemistry after going home, after leaving the class. Good, good, good. So far, everyone have answered right. So far, everyone have answered right. Good. Everyone is answering right. Okay. That's good. Very good, guys. So far, I saw everyone answering correct. Zinc and copper sulfate. Copper comes after hydrogen. Zinc comes before hydrogen. So what does it mean? Zinc is more reactive, isn't it? So zinc is more reactive. It would be replacing copper from its position. And the resultant solution is zinc sulfate. And the color of zinc sulfate, anyone in the class? Color of zinc sulfate? No, not green. Green is iron sulfate, pale green. Not blue. Blue is copper sulfate. Violet is solution of iodine. Reddish brown is iron, iron chloride, FeCl3. Colorless, very good. It is colorless. It just looks like water. Yeah, right? So we'll be able to see the color change from blue to colorless, right guys? So this is all about the questions which I wanted to ask, and I have a very, very important question for all of you, and the question is there on the screen. Answer this question. No, Rohit, answer this question and then bye. This is 100 marks question, Rohit, not 20 marks and all. Yeah, well guys, so this is all about our today's class. We were talking about chemical properties of metals and non-metals. Parallelly, we spoke about reactivity of metals and non-metals with oxygen, metals and non-metals with water, correct? And in the next class, what we shall be doing is we'll continue with the chemical properties. But before that, I have a task for all of you. And the task is, take a look at this. We are done till this page, right? Page number 43 is done, correct? Yeah. And now in the next class, try to go through page number 44 and try to go through page number 45 as well. Do you see this image on page number 45? Yeah, do you see those test tubes and all? Do you remember something? Studied in first chapter? Do you remember this series? Metal reactivity series? Page number 45? Yeah, we are done with this also in the first chapter. So next class till page number 45 in this chapter, I want everyone to come prepared. So first 15 minutes you are going to have an official quiz. I'll be sharing link with all of you. Based on this all details, you would be writing, you would be giving the answers in that link. After that, I think I can ensure you will get your results then and there. If not, I'll send you the result. Yeah, right? Good. So come prepared till page number 45. I'll see you all in the next class. See you guys. Bye-bye. And if you have any doubt, please stay back. Please stay back if you have any doubt. Bye-bye, Harshit. Bye, Vaishnavi. Ankit, bye-bye. Good night. Sweet dreams. Hey, thank you. Well, bye-bye, everyone. Aluminium is not a noble metal, Hiba. It is a lower reactive or moderately reactive metal. Yeah. Only two noble metals we study, gold and platinum. Okay. Bye, Zubin. Bye, Hiba. Pavitra. Bye-bye. Good night. Bye, everyone. I don't see anyone asking doubts. Why does magnesium not react with water? Because magnesium is moderately reactive. It doesn't have that capacity to react with normal water. It needs some sort of energy, some sort of push-up. And that is acquired with the help of kinetic energy. And you can give kinetic energy when you heat water. Yeah, so hot water is feasible for reaction with magnesium. No, tungsten is the least reactive. That is least. And it has high melting point. That's why we use it in the electrical bulbs. Right? Well, for NTSC help, yeah, Harshita, why not? You can. Right? Well, I see almost everyone in the class have left. I hope there are no more doubts. In case there are doubts, I'm always there in WhatsApp, guys. So please reach me out for any sort of help in chemistry. Bye-bye, everyone. See you all in the next class.